Hey, okay, welcome back. Let's get straight into vectors. I don't think they're part of pre-calculus, but they are pretty important. If you have watched Despicable Me 1 and paid any attention to the main villain Vector, he'd actually help you out with understanding this, as by definition, vectors have two things, which are direction, not directions, and magnitude. That is how they differ from just the regular array or line. And we can really see this in I please don't do this to me, OneNote. We can really see this in many areas. So let's draw this out for now. For example, let's actually make out a vector to draw. Let's say this point is 4 3. And then there are actually a lot of ways to write this out in vector form. The first is just, I think this is called vector form. I'm really not sure about the names. However, you can write this down as just simply 4 3. Just remember, your brackets do have to look like the vector brackets, which are like this. You'll have A and B. I already wrote that, so I will just be erasing this. The other way that you can write your vectors are taking in account of the magnitude. Magnitude is similar to distance, and you'd use a form of Pythagoras theorem to find that. Here we can just do 3 squared plus 4 squared, which is actually equal to 25, and then the radical of the squared version of that is just 5. So we now know that the magnitude is equal to 5. Magnitude is represented like this, and the magnitude of this vector is equal to 5. So we do have the first component of the second form. Let me just write first form right here. That's number 1. Number 2, we can take the magnitude and multiply that by the direction, which can be represented with cosine theta and sine theta. Here we've already found the magnitude, which is 5, and we can multiply that by cosine theta. Theta here, we can just use our arctangent, arcsine, and arccosine to figure this out. We can do cosine of arctan 3 over 4. 3 over 4, because it is y over x. That is how that works. And then comma sine, let's move a bit to the side, and thank you, OneNote for lagging, arctan, please stop, 3 over 4 for the second way of writing this. This is a times, and I think this is called the magnitude direction form. I'm not sure. Additionally, another important thing to know is the component form, and the component form is actually very fun. When firstly talking about vectors, it's important to know the ways you can represent things, and they're often represented with I, J, and K, with I kind of being the X, Y being the J being the Y, and K being the Z. Here, this is equal to, if we write it down in the normal vector form, 1, 0, 0. I'll use 3 dimensions here, just because I'm using the 3 variables. Here, this is equal to 0, 1, 0, and here, this is equal to 0, 0, 1. Okay. Component form really just utilizes this and kind of mixes the top form that I mentioned up here. So instead of using the brackets, we would just say that, let's say the vector, which is represented like this, equals, like we said, the x value is 4. So we would say 4i, and since the y is positive, plus 3j plus 0k. We don't need to represent k, but because I mentioned it, I have added it here. And finally, the final form is the word form that we use in class, which I'm not sure what is known as, but there it's kind of what we take with to return it into words. We would say 5 units, which is the magnitude, 5 units, and then the direction, which is 5 units arctangent 3/4. And this is not it. And then we mention above or under which version of the x-axis to help understand what values are positive. So those would be above the x-axis, or as we mentioned earlier, represented with I. Those are all the ways that you can write out vectors. Another important thing to know is what a unit vector is. A unit vector is simply a vector whose magnitude equals 1. In order to find a unit vector, really what you can do is find the reciprocal of the magnitude. So let's say we're still using 3, 4. The reciprocal of this, of its magnitude, would be firstly finding the magnitude, which we did earlier, was 3 squared plus 4 squared equals rad 25 equals 5. So now that we have the magnitude, we can take its reciprocal, which is 1/5, and multiply that by both values, which would equal 3/5 and 4/5. When you take the reciprocal, when you take the magnitude of this, you'd end up getting 1, which therefore makes it a unit vector. Additionally, when working with vectors, oftentimes you'll usually hear about dot products and cross products. Dot products are represented like this, if OneNote allows me to write. A dot product is often represented as A dot B, and it is a form of multiplying two vectors together. Dot products help us find the angle between two vectors. Sorry if my handwriting is poor. The worse I make it, the smoother my OneNote experience is. Let me unpause my music. Find the angle between two vectors. What you usually end up doing is dot products give you they give you a whole number usually as your answer, or not a whole number, but I think the proper word is scalar. A scalar is really just like a factor which you multiply things by, so kind of like a coefficient. And in order to find the dot product, you actually it's really pretty simple, and I'll show it right now. Let's give ourselves vector 1, and let's say here are the A and B values. Let's say 3 and 4. And here is vector 2, which is let's say 1 and 3. So to find the dot product, we can simply do A1 times A2 plus B2 times B1, and then if there were a Z variable, you do C1 times C2, and you'd add that all together. And let's do that here. I'll give you time to practice. You can pause, try this out, and then unpause. You can pause now. Unpausing time. Let's go. Let's have a1, which is 3, times a2, which is 1, plus b2, which is 4, and b1 is 3. We end up getting 3 plus 12, and we end up getting a dot b equals 15. So this would be the scalar that gives us our answer. But really, to find the angle, here is what we can do. A dot b can also be written in two other ways, with that being magnitude of a times magnitude of b, all times cosine theta. It can also be written as, and in order to really derive cosine theta, we can just solve for it using this equation, where it's a dot b all over magnitude of a times magnitude of b. So we can try that out right now to find out what theta is. We know that we'll use this equation right here. We know that oh my bad, cosine theta is equal to 15 over magnitude a times magnitude b. The magnitude of a, we've already done this, that is equal to 5. So we'd have 5. I don't know, I put the lines next to it. Lines go away, please. There we go. 5 times magnitude of b. B here is this one. And we can do 1 squared plus 3 squared. And we take the radical of that answer, which is 1 plus 9. And radical 10 is, and which is equal to 10. And we take the radical of that, which is rad 10. Which is equal to times rad 10. So here, cosine is, we can say theta, because we aren't really able to get an answer right now. We can say, like a fun answer, we can say cosine of -1 is equal to 3. We can simplify this. 3 over rad 10 equals theta, and this is how you get the angle. That is the gist of dot products. They're really used for finding scalars and the angles. And then when the angle is equal to pi over 2 or 3 pi over 2, so whenever it's perpendicular, the dot product is always going to be 0, because that's when cosine is actually 0. So if we do cosine of 0 times a times b will always be 0. That's a fun way to figure out whether or not you found the right thing. And now let's go on to cross product, which you will need a bit of matrices understanding here. The cross product, that can be written as, it's usually written as axb, and that is equal to magnitude a times magnitude b times sine of theta. Additionally, axb is actually equal to the, alright, here's the setup. You usually have 3, or you can also just use I and j to make another square matrix. But you'd have this, and you'd have like a, b, c, d, e, f. A, b, and c would be the points from vector 1. So let's give ourselves vector 1 right now. Vector 1 is equal to, let's put it in component form, 2j plus 3k minus 2. Oh, I just shifted all the letters. You know what? Minus 2i. Sorry, that will be out of order. And v2 equals -1i plus 3j plus 4k. So what we can do now is we can plug in our values of ax and b. So I, j, and k will always be there. Now we have negative 2, 3, 2, and then negative 1, 3, and 4. What we do now is find the indeterminate. I'll give you guys a simplified equation, but one thing to remember when finding the cross product is that really we're finding an orthogonal or perpendicular vector, and that is what's gonna help. That is usually what this is used for. Perpendicular. Let's see if I can erase this since I continued the stroke. Yeah, it's permanent. Perpendicular vector. And now let's continue. To find the indeterminate, really what we can do is we can firstly cross out I. Let's pretend this don't ever exist. And we can find the indeterminate by doing AD minus BC. That is how you find the 2 by 2, a 2 by 2 indeterminate. Let's do that right here. A and D is 3 and 4, so 3 times 4 is equal to 12, minus 3 times 2, that's equal to 6. And this is what I will be equal to in the new vector. Then we then subtract the j vector, and now we're gonna get rid of j. So now this is orange, and we're gonna ignore that. So now our new a and b values, a, b, and c, and d. This is going to be a. This is going to be d. This is going to be b, and this is going to be c. Let's do AD minus BC. 2 times 4 is equal to negative 2 times 4 is equal to negative 8, minus 2 times negative 1, which is negative 2. And then finally we add our k value plus k. Our k value, we get rid of the k column from our mind. I just made it a darker pink. Let's try blue. We get rid of this from our mind, and we now focus on our new 2 by 2 points. Here we'll use 2 and negative 2 and 3 as our a and d, and our b and c will be 3, negative 1. So let's do AD minus BC. Here AD minus BC is equal to negative 2 times 3, which is negative 6, minus 3 times negative 1, which is negative 3. I missed the minus sign right there. And let's finish our work here. 12 minus 6 is 6. 6 times I is 6i. Now negative 8 minus negative 2 is negative 6, because that's negative 8 plus 2. And times negative j is actually going to make that positive. So positive 6j. And then negative 6 minus negative 3 is negative 3, times k is going to be negative 3k. And this is going to be our perpendicular vector to the original 2 vectors that we got. Another thing we can do is learn the right hand rule to help figure out these kind of vectors. Let's say someone told us that we had a vector going left and south. The first thing you would do is you take your right hand, and the first direction would be where you point your index finger, or wherever's next to your thumb. I'm forgetting. So you'd point this leftward, for example. I'm sorry, I can't really show it too well because, I'm on OneNote. And next you take your middle finger and point that in this direction as well, and south. So I want you to take your right hand, please make sure it's right, point to the left, then take your middle finger and make that go south. Then whichever direction your thumb is pointing to, is the direction is like the direction of the perpendicular vector, and that is the right hand rule. If it's pointing towards you, that'd be like a negative k value, and if it's pointing away from you, that is a positive k value. When it comes to like up and down or left and right, then that's just I and j, positive and negative. That's pretty difficult. I hope this was able to help you all, and have a great day. Stay 7.